Hey, thanks for tuning in to Check This Out Mathematics. And hey, since it's at the beginning of the video, let's do the necessities here. Please subscribe to my channel and give some comments down below, and give me a thumbs up for these videos, and check out all my other videos on Check This Out Mathematics. Okay. So currently we are doing lessons on logarithms. Okay, very exciting stuff. Okay, and previously we talked about this concept that here is an exponential expression, b to the n equals x. And we can change that to a logarithmic expression, log base b of x equals n. And so here, the exponent here is n, or the power is n. And so here we have log base b of x, and the answer here is n. And so a logarithm is asking, what is the power? Because here's the power n, and here's the power n. And here, a log base b of x is saying, what power of b gives us x? Well, b to the n gives us x. And so log base b of x equals n. And to understand this relationship further, we have this round trip, that if we have b to the n equals x, and that is implies that log base b of x equals n, then we can make this round trip from beginning at b around to n and back to x. And that takes us to the beginning expression, b to the n equals x. b to the n equals x. Okay, and so let's do some examples on this round trip and this concept of what a logarithm is. What is the power? And it looks like you didn't write this correctly. Logarithm. Okay. Let's put that down. M S are asking. Okay. Logarithms are asking, what is the power? That's it. Okay. So let's check these problems out here. All right, we're going to start with this one here. Finding the power. Okay, that's what we're. That's the theme of these problems that we're going to be working here. Finding the power, because that's what a logarithm is. It's an exponent. A logarithm is a power. Okay, so let's look at this first example. We have log base 6 of 6. Okay, so here's the problem that we're trying to find an answer to. And so whenever you see something like this, what you want to do is imagine that there is an equals and a blank. Okay? And so now we put that equals in the blank there, and we say, what is the power that makes 6 become 6? Okay? That's again the back to this idea. What is the power that makes b become x? Well, it's the n power of b that gives us x. The n power of b that gives us x. That's what a logarithm is asking. What is the power? And so what is the power that makes 6 become 6? And so you can rewrite this and say 6 to what power is 6? Okay. 6 to what power is 6? And that, of course, would be the first power. Okay. So 6 to the first power is 6. And so the log base 6 of 6 is 1. Okay. So 6 to the first is 6. What's the power that makes 6 become 6? Well, it's the first power. Okay. 6 to the first is 6. All right, let's try another one. Example 2. All right, this time we have log base 12 of 144. Okay, and so oftentimes the problem will be given to you just like this, and you're kind of wondering, what do I do with that? And so what helped me to understand these types of problems in the beginning was to put the equals in the blank there. Okay, and realize that the logarithm is asking a question. What is the power? What is the power that makes 12 become 144? And so you can rewrite that and say, what is the power? Okay, so start by putting your blank here. Start by putting your blank here, and then put your 12. And then put your 12 there. So it can say what power of 12 is 144. Okay. And so both of these statements are asking the same question. What power of 12 is 144? What power of 12 is 144? That's what the logarithm is asking. And so you would say, oh, I know. 12 squared is 144. 12 to the second power is 144. And so then that's what we can put as our answer to the logarithm. Okay? So 12 to the second power is 144. So log base 12 of 144 is 2, because 12 squared is 144, making that round trip happen. Okay? So each time you're trying to solve or find an answer to a logarithmic statement, you're using this round trip. Okay. Okay, and so that's why we want to put that blank there to begin with. Okay, so 6 to what power is 6? Okay, make that round trip. 6 to the first is 6. And 12 to what power is 144? 12 to the second power is 144. And so you can change this logarithmic expression into an exponential expression and help you to realize the answer. All right, let's do some more problems. Okay, let's see. All right, here we have example 3. And this is log base 7 of 343. Okay, what kind of problem is this, Mr. O'Donnell? I mean, I have no idea. Well, you're stuck on something like this. Well, no, you're not stuck. You have the power to figure these problems out, right? Put your equals and put your blank. All right? And then turn it around using your round trip. 7 to what power is 343? And so what power of 7, you see I started by putting my power here, and then I put what power of 7 is 343. Okay? And so now go back to this, this is the question here. The logarithm is asking us, what is the power? And you know, in this previous problem here, we kind of knew it instantly. 12 to the second is 144, because it's something that we knew, right? But what if we didn't know? You know, we might say, okay, how many 12s do I need to get 144? And so you might have to think about that. You say, oh, 12 times 12. Oh, hey, that's 144. So I need to multiply 12 by itself to get 144. I need 2 of them. Well, maybe we can do that same idea with this problem. How many 7s do I need to get 343? Now let's see. 7 times 7 is 49, right? Okay. And then let's multiply by another 7. Okay, 9 times 7 is 63. And carry the 6. 4 times 7 is 28. And 6 more, 4 times 7 is 28. And 6 more, oh yeah, that's 34. Yeah. Okay, I need 3 of them. So there's the answer, right? You can fill in the blank there. What power of 7 makes 343? Well, it took 3 7s to get me to 343. And so then, that's my answer. 7 to the third is 343. And so therefore, the log base 7 of 343 is 3. Okay. All right. Now, you know, I kind of like this idea here. You know, you're trying to multiply 49 times 7, right? Well, let's see that this makes sense here. What's 50 times 7? Well, that's 300. That's 350, right? And so I actually don't want 50 of them. I only want 49 of them, right? So how about that's 1 7 less, right? Okay, so 1 times 7 is 7. Okay, so I don't want 50 7s. I want only 49 7s. And so I need to take away one of those 7s. And 350 minus 7, oh yeah, that's 343. Yeah, so it is true. 49 times 7 is 343. Okay, so that's a nice little idea to make it conceptual. Make your multiplication conceptual. That if you wanted 49 sevens, well, that's the same as 50 sevens, take away a 7. And that's how you get that 343. Okay, cool. All right. Let's do another problem here. D. Example D. Okay. So, example 4. Here I have the log base 4 of 1024. Okay. Okay, and so here again, the problem might just appear to you like that. You're going, I don't know what to do with that. Well, sure you do. Mr. O'Donnell taught you what to do here. Okay. Put your equals in your blank and put your 4 to what power is 1024. Okay. All right. Now then, start multiplying. Right? Because we're trying to find the power. What power of 4 is 1024? So how many 4s does it take to reach 1024? Well, let's find out. All right, so 4 times 4 is 16, times 4 is 64, times 4, okay, 4 times 4 is 16, carry the 1, 6 times 4 is 24, 25, 256, okay, and so it looks like we're at 1, 2, 3, the 4 to the 4th is 256. Hey, that might come in handy there. 4 to the 4th is 256. All right. Let's see. We're not quite to 1024, so let's multiply again here. 256 times 4. All right. 6 times 4 is 24. 5 times 4 is 20, 21, 22. Uh-oh. Look at that. Something's happening there. 5 times 4 is 20 and 21, 22. And then, so carry the 2 again. 2 times 4 is 8, and 2 more makes 10. 1024. Okay, so that is 1, 2, 3, 4, 5. 4 to the 5th is 1024. Okay, so let's put that in there. To the 5th. To the 5th. Okay, so what's the power that makes 4 become 1024? It's the 1, 2, 3, 4, 5th power. 4 to the 5th is 1024. So we have found the power that makes 4 become 1024 just by multiplying. You can do that, right? Okay. All right, a few more problems for this video here. Let's sample this one. Okay, try this one on for size. Okay, example 5. Okay, so we have log base 49 of 7. Okay, you're coming over with some strange problems here, Mr. O'Donnell. What power of 49 is 7? How does 49 become 7? I mean, does that really happen? Okay, well, put your equals in your blank there. And then turn that around and say, what power of 49 is 7? Okay, remember we're doing our round trip here. 49 to what power is 7? 49 to what power of 7? Okay? And so remember that round trip there. And now ask yourself, how does 49 become 7? And you might have this bright idea that the square root of 49 is 7, right? Oh yeah. And now when we have a square root, we want to remember that that you have this 1 here, and this 2 here. Okay? So when you have the square root of 49, the power is here. It's the 1/2 power, right? The 1/2 power. 49 to the 1/2 power is 7. Okay? And so what power of 49 gives us 7? Well, we have to raise 49 to the 1/2 power to get 7. To get 7. We have to take the square root of 49. And that's what it means here. The square root of 49 means 49 to the 1/2 power, right there. Okay? And now, remember, there's another way that we could write this. We could say log base 49 of 7 is the same as the log base 49 of the square root of 49. Okay? So the square root of 49 is 7. And so the log base 49 of 7 is the same as the log base 49 of the square root of 49. And oh, wait a second, didn't we have a property about that? Oh yeah, remember way back in those other videos that we did? Yeah. Okay, that you watched, of course, right? Yeah. Okay. And you gave me a thumbs up, and you liked, and you gave some comments, right? Okay. And you subscribed to my channel. Okay. And so here, log base b of the square root of b is 1/2, because b to the 1/2 is b. Okay, and where is that 1/2 coming from? Well, it's when we talk about a square root, we're talking about the 1/2 power here. And there's the 1 and the 2 there. You see that? Okay. B to the 1/2. The 1 is the numerator, and the 2, your root, is your denominator. Okay, and so that's what we're doing right here. Log base 49 of the square root of 49 is, how do you make 49 become the square root of 49? Well, you need the 1/2 power to do that. Okay. Okay. All right, so that's more insight to what's happening in that problem. Okay, let's do a few more. All right. B, E, F, G, and H. Okay. I'm going to do a few more problems, then I'm going to give you some problems to work. Okay. All right. So here we have another doozy here. Example 6. Log base 4 of 0.25. What? Uh, please help me. Okay, I am going to help you. What are we going to do? We're going to put the equals in the blank, right? And then we're going to imagine what power of 4 is 0.25. Okay, so now remember, 0.25 is a fraction, right? So 0.25 is 25 over 100, right? Yeah. Okay. And, oh yeah, you might remember that as 25 times 1 and 25 times 4, and so you might remember that as a fourth. Oh yeah, I knew that already. 0.25 is a fourth, a quarter is a quarter. Yeah. Okay, so you mean that now I can say the question is, how does 4 become 1/4? Okay, how does 4 become 1/4? Because that's what 0.25 is. It's a fourth. Oh, I know. How do you make fractions? You need a negative exponent, right? Yeah, and that negative exponent is -1. 4 to the -1 is a fourth. Okay, so then that goes here, and that goes here. Okay, 4 to the -1 is a fourth, and a fourth is the same as 0.25. So 4 to the -1 gives us 0.25, and so that answers the question. What power of 4 gives us 0.25? The -1 power. Okay, awesome. All right, let's do another problem like that. Okay, example 7. Okay, let's see if you've got this, right? Okay, so we have log base 20 of 0.05. Okay, well, what do? We put a equals and a blank, and then we turn that around. What power of 20 is 0.05? What power of 20 is 0.05? What power of 20 is 0.05? Okay, so let's see. Now, 0.05, well, that's like a nickel, isn't that? Right? Okay, so 0.05 is a nickel, and so that's 5 cents out of 100 cents, right? Makes sense, right? 5 cents out of 100 cents. Okay. And then, well, that's 5 times 1, and 100 is 5 times 20, isn't it? 5 times 20. Okay. And so then the 5's divide out. And we have a 20th. Okay, so 5 cents is a nickel. And you need 20 nickels to make $1 there, and so a nickel is a 1/20th of $1. How many 1/20ths do you have in your pocket? Okay, nobody says that. All right, so now we can realize that it's 20 to the negative 1. That gives us 1/20th. And 1/20th is a nickel. Okay? And so there it is again. -1 is our answer. Okay. So what power of 20 gives us 0.05? It's the -1 power of 20 that gives us 0.05. Yeah. Okay. All right. One more problem, and then I'm going to give you a list of problems for you to do. That'll be so exciting, right? Okay. So now, this is example 8. And this time, we'll do example 8 and 9. Okay. Okay, here I have log of 1,000. Now, Mr. Don, aren't you supposed to write a base here? Yeah. When the base is not written, it's understood to be base 10. Okay, base 10. Okay, and so now we're asking the question, what power of 10 gives us 1,000? Okay, and so you would say, oh, I know, 10 to the 3rd power is 1,000. Okay, and so when there's not a power given, it's understood to be base 10. Okay, and so what power of 10 gives 1,000? 10 to the 3rd is 1,000. Okay, and so now we can fill in our blank there. 10 to the 3rd is 1,000. Okay, and now just to ramp it up a bit, what if we had this one? Example 9. If we had log base 10 again, we don't have to write it because we know it's base 10, of 1 over 1,000. Okay, how do we get a fraction? With negative exponents. Okay, and so the understood base here is 10. Okay, and we're wondering 10 to what power is 1 over 1,000. So we put our equals in our blank, and we say 10 to what power is 1 over 1,000. Okay, and so if we want 1 over 1,000, that's the same as 1 over 10 to the 3rd. And so how does 10 become 1 over 10 to the 3rd? Well, it's the -3 power. The -3 power. 10 to the -3 is 1 over 1,000, because 10 to the -3 is the same as 1 over 10 to the 3rd, and that's 10 to the 3rd is 1,000. Okay, so you see you can do those problems as well. All right, now here's some fun problems for you to do. We're going to write them down. Okay. All right, let's see. Let's do this one. For you. Okay? Don't say I never gave you anything. Okay? Because these problems are for you. Okay, so problem 1, log base 81 of 9. Okay. And problem 2 is going to be log base 6 of 1,296. And problem number 3 is going to be log base 2 of 256. Okay, nothing multiplying for you to do there. Okay, and problem number 4, more multiplying for you to do here. Log base 5 of 15,625. Come on, Mr. Dunn. No, 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 I'm serious. Try this. Okay. And then let's put this one here. Log base 11 of 1,331. Okay. And number 6, we have log base 50 of 0.02. Okay. And let's see. Oh, here. Number 7, log base. We'll just leave it like that here because you know what the base is going to be, right? And we'll put 100,000 here. Okay. All right, and one more just to finish it off. How about what is the log base 8 of 8? Okay. Okay. 8 problems for you to do. Okay? Tell me how you did in the comments below. All right. Awesome. Okay. Thanks for tuning in to check this out, mathematics. And give me a thumbs up for this video. And subscribe to my channel. And put some comments down below. We are going to continue these lessons on logarithms, and we'll do some more examples in the next video. Okay, Mr. Dollars, see you later.